Hello there, welcome to this session on coroutines. What we will see in this session is how we can run two programs simultaneously in a shell, as well as what happens if I run these two programs through a script, a shell script. So, before we go into how to run programs in the background and how to run it using shell scripts, let us try to understand what is a coroutine. When two or more processes are explicitly programmed to run simultaneously, possibly they are communicating with each other, then we call them as coroutines. So, let us take an example. We know that if we type a command called ls space minus l and then we pipe it to grep, what will happen is that it creates two processes. Okay, the first process is ls space minus l, which is actually a series of system calls, and then grep is another process which is another series of system calls, and then these two processes are related through a pipe symbol, which essentially means that the output of process 1 becomes the input of process 2. Okay, that is, the standard output of process 1 becomes the standard input of process 2, and here there are two things that are happening. One, the programs are running in parallel, and two, one program is communicating with the other program. Now, what happens, the shell, what it does is that it waits for both the processes to finish and then it comes out, and then user will be able to type in more commands. So, in this case, for example, let us try this example and see what happens. Okay. So, here what I do is I put ls minus l and then I put a grep, okay, and then I say, let us say I put December, I want to search for December. So, what is happening is that it first, after both the programs are executed, that is ls minus l and grep are executed, it returns back to the shell. Now, essentially what happens is that the shell waits for both the processes to finish and then it comes out. Now, let us consider another scenario. So, in this scenario, what we are going to do is that we are going to find out how to get multiple processes to run at the same time if the processes do not need to communicate with each other. So, remember, in the previous case what happened is that I gave a ls minus l command and the output of the ls minus l became the input of the grep command. Now, let us say that we do not want such a communication to happen. That means, each process must execute independently of each other. Okay, so, for that what we can do is we can run the processes using in the background, and for this either you can use the and symbol or you can use the bg command. I mean, there are two ways. What you do is you just run the program, then put control, make the process go to sleep, and then you type the bg command, and then the currently executing process actually goes to the background, and then you can start typing new commands. Now, the question is, so let us try to see how to use the background process. So, I have two programs. So, let us say I call them as first p.sh. Okay. So, what this program simply does is it just takes initializes a value of n to 10, then it goes on decrementing 10 by 1. So, it prints 9, 8, 7, 6, 5, and then between printing 9, 8, 7, 6, 5 and so on, it sleeps for about 5 seconds. Let me take another program which is known as second program.sh. So, in this program it is the same logic except that I sleep for only 1 second. So, which essentially if I start these two programs, then if I start at the appropriate time, the second program should end before the first program, and if you run the first program in the background and the second program in the foreground, what will happen is that you will get the shell prompt as soon as the second program exits. So, let us try to see what is happening here. Okay, so, if you look at this, I can just say type first p.sh and then I move it to the background, So, this program will start working, the process ID is 26977, and then I can just see what happens with this process ID 26977. So, it says 26977. The most important thing to look at is that the process ID 26977, the parent process is 25047, okay, 25047, which is the bash. So, the parent of 26977 is 25047. So, keep this in mind, this is very important because this is where we are going to explain. So, something. So, now again coming back, so let us now try to let this program end, so that we will now run both the programs in the background, see both the first program and the second program. So, this program is ended. So, we will run both the programs in the background. So, first.sh is run, then I will also run second.sh. So, what happens is that the second program.sh will actually finish before. So, it starts 987. So, it goes very fast and then it finishes before the first program, but then you start getting the shell prompt. So, now I can take a look at the shell prompt and then I can guess for first .sh. So, then the first program also exists and so on. So, what we can do is, so the first program is executing. So, if you see the first program is running. So, the idea is that these two programs are working independent of each other. So, this is an example of a coroutine. Now, so let us go back, and if you look at what had happened. So, if you look at this program 26977, okay, and the bash shell was here, okay. So, the parent shell was here, okay. Now, and your parent shell was live. When I say live, when I say the parent shell was live, you had a program that was working in the foreground, you had a program that was working in the background, and both came out of the same shell. Now, let us consider a case where we put these two programs in the form of a shell script. So, let us consider the case where we put these two programs in the form of a shell script. So, something like this. Okay. So, in this case what happens is, when I run this program, this coroutine.sh program, what will happen is that I am trying to put the first program in the background, okay, and then I am trying to put the second program in the foreground. Okay. So, everything looks fine here. So, what is happening is that, so when I run this program, okay, so the coroutine.sh is working. So, if you look at this, both the programs have started working and it has come out, okay. So, since the second program has exited, it has come out, okay, and now let us try to see jobs, okay. So, there are no background jobs. So, look at this, there are no background jobs, okay, but still your program is running. So, what is happening is that it says there are no background job, but still their programs are running. So, why does this happen? Is it because when I executed this coroutine.sh, okay, coroutine.sh, the coroutine.sh had a process ID and that spawned two processes, okay. The first process was first p.sh and the second process was second p.sh. Okay. So, because of which, so let me run this program again, this coroutine.sh. So, it created two processes. Okay. So, if you look at this, so it has created two processes. So, you can see two bash shells. Okay. So, it has created, one is sleeping for 5. So, it has created two processes. Now, what is happening is that, so if you look at this, now the first process has died, then there is the second process that is still going on and on and on, okay. And what is happening is that the second process you are not able to see using the job command, because you did not execute this from the current shell. See, the current shell has already died, because the current program which invoked this has already died, because of which you are not able to see using the jobs. Okay. So, essentially then if the current shell has died, that means the coroutine.sh has died, then how is it that your program is still working? So, here is one of the things that we know. Okay, so, if you run the program from the shell, okay, for example, if you run the program from the shell, then as soon as the second program gets over, that is second p.sh gets over, what is happening is that the first program still runs in the background. Now, how is it possible that your shell has already, your coroutine program has already existed, but the program that created that first p.sh has exited, but then the first p.sh is still running. So, what happens is that the first p.sh will actually get orphaned when the second process exits early. Okay, that is why when you type the jobs command, you are not able to see that process. Now, the question is, how do I know, or what do I do to ensure that I come back to my shell only after the background process as well as the second process that I start ends? So, what I essentially say is that when I give this command, okay, coroutine.sh, it should not exit immediately after the second program inside coroutine.sh exits. So, in this case, for example, the first and the second programs are running, and look at this. At this point, the second program has exited, therefore, I have come back to the shell. You know, I am able to type any command that I want and I can get the result. At the same time, there is something that is running on the background. Now, once the coroutine.sh exits, the first p which is running now gets orphaned, and it is running with its parent shell, the coroutine's parent shell. So, it is working at the background, but then now I do not want this to happen. I want to come to this shell, and I should be able to type any command only after first p and second p gets over. So, what I do is, so in this case we have to use a command called wait, and what it does is, so if you, I will edit this file called coroutine.sh. So, in this coroutine.sh you see I am doing the same thing, but then what I do is I type the command called wait. Now, if I type the command called wait, so let us see what happens. So, I run this coroutine.sh. Now, you see the first program has started, the second program has also started, and let us see what happens. So, now the second program is going to end, and still you have not got the prompt. So, look at this, you have not got the prompt. So, what is happening now is your shell is actually waiting for the background job to complete. So, actually if you look at this, the first program is still running, we have 8, 7, 6, 5, 4, 3, 2 and 1, and only after that you will get back your shell prompt. So, in this case now, can you get this effect by normal shell programming? I leave it as an exercise, try to find out whether you are able to do it or not. See, now we have got back the shell. So, what this wait does is that, so if you, let us go back to the code. So, what this wait does is that it executes this first program and second program as a coroutine, but then waits until all these programs are completed and then it exits. So, if you remember, in this case we prevent the first guy, okay, or the first program from becoming an orphan. So, you would have heard about the word orphan, that is when the parent process gets killed or exits, then the child process becomes part of the system. Okay. So, in this case we prevent the first process from becoming an orphan by putting the wait command. Now, if you look at this, so if you can solve the problem of coming back to your shell, okay, before all the programs are completed by putting the wait command. So, the other thing that you can do is that in this wait, okay, if you can give the process ID, then you can say if your script has more than one background, say for example, I have first P, second P is also background, third P is also background, and then fourth P is running in the foreground. Now, suppose I want all of them to complete and then you want to come back to the shell, then I can just type wait at the end of the shell script. Now, if I want only first P to be completed, then I can give the wait for the specific process ID and then find out how to exit. Now, in this way we will ensure that all the processes are completed before I go to the next execution of the shell script. See, this is the idea. Okay. So, sometimes if you use this, if you do not use wait, what happens is that the current shell goes off, one process becomes orphan, and then capturing the output of the process and processing it, you could get some errors. So, in order to avoid it, what you do is when I say wait, then it waits for all the process to finish up to that point, and then it continues execution after this point. So, now what are the advantages and disadvantages? So, why should I talk about this, or why should I know about this? Okay, if you use coroutines, okay, the advantage is if a computer has only one processor, let us say, you might actually have a slight improvement in performance rather than executing them serially. Okay. So, this is a sort of a parallel processing that we are looking at with shell itself. Now, if you look at this, and will this be really useful? Yes, because not all shell commands or commands that you run on Unix take the same amount of CPU or input output or interactive. So, your whole performance of any program depends on what is its usage of CPU, what is its usage of input output, what is its usage of interactiveness. Now, any process can differ with respect to these three criteria, and therefore, you can running them simultaneously, you will be able to really able to time share between two processes, and actually sometimes it might so happen that if you want to run two independent processes, you can run them together by using these coroutines. But ensure that if you want all the processes to complete and then proceed, you use something like wait. Okay. Can this coroutines have disadvantages? Yes, probably. What could happen is that if there are two processes that use resources in the similar way, okay, remember these two processes should be independent of each other, because if they are dependent, then one output should be given to the other's input. So, that is like piping. If they are independent of each other, then you can definitely get some kind of performance improvement. Of course, it depends on, can you really guarantee performance improvements? In most of the cases, yes. In some cases, probably no. When they use the same resources or same CPU at the same time, etc., then it could slow down. But this definitely can be used to speed up your shell scripts.